Okay, Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3 and we will be presenting to you about the thermal conductivity of solid. Now, we will start with the objective that will be presented by Faris Iqmal.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris bin Johari. Today I will present to you the objective of this experiment. The purpose of this experiment was to determine the thermal conductivity of specimens connected series. Beside that, this experiment also to identify the heat conductivity K of different building materials, and last, this experiment also we use it to determine the thermal resistance of materials.
In this theory, it also involves continuum mechanics. What is continuum mechanics? Continuum mechanics is a branch of mechanics that deals with the mechanical behavior of material modeled as continuous mass rather than as discrete particles. The French mathematician Auguste Lustin Cauchy was the first to formulate such models in 19th century. Alright, what is the concept of continuum? Materials such as solids, liquids, and gas are composed of molecules separated by space. On a microscopic scale, materials have cracks and discontinuities. However, certain physical phenomena can be modeled assuming the materials exist as a continuum, meaning the matter in the body is continuously distributed and fills the entire region of space it occupies. A continuum is a body that can be continually subdivided into infinitesimal elements with properties with those the bulk material. The validity of the continuum assumptions may be verified as a theoretical analysis in which some clear periodicity is identified or statistical homogeneity and ergodicity of the microstructure exists. Okay, that is the concept of continuum. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif bin Jumali, and today I will present to you about the additional theory of the experimentary, that is thermal conductivity in solid. Okay, first of all, the additional theory. I will make this simple because the additional theory is quite long, so I will shorten it. Okay, first of all, the additional theory. The boson of elastic continuum are well known as Debye boson, that is sun waves. Since the translational symmetry of the elastic continuum is invariant with respect to the transformation of the length scale, the momentum of the Debye bosons is a conserved quantity. Debye bosons therefore propagate ballistic over large distances, rather independent of atomic structures and crystal imperfection. This propagation mode can be termed universal. The ballistic propagation mode makes Debye bosons particularly suitable for heat transport. Okay, first of all, what is Debye bosons? In thermodynamics and solid state physics, Debye boson is part of the Debye model. What is that? The Debye model is a method developed by Peter Debye in 1912 for estimating the phonon contribution to the specific heat capacity in a solid. It treats the vibration of the atomic lattice that is heat as phonons in a box in contrast to the Einstein model, which treats the solid as many individual non-interacting quantum harmonic oscillators. So, Debye models is completely opposite to the instant model. The Debye model correctly predicts the low temperature dependence of the heat capacity, which is proportional to T3, that is Debye T3 law. Just like the Einstein model, it also recovers the Dirac-Philip law at high temperatures, but due to simplifying assumptions, its accuracy suffers intermediate temperature.
Assalamualaikum and very good morning. My name is Lutfi Rahman bin Dud and I will present about procedure for this experiment. First, we need to prepare specimen. The specimen we use is PMMA, plaster, cardboard and polystyrene. So we need to prepare the specimen. After that, prepare the HE116 thermal conductivity, and then make sure all the apparatus will be functioning very well. And then take the polystyrene specimen and measure and record the length, width, tightness of polystyrene specimen by using vernier caliper. Next, calculate the area of specimen by using formula length multiply with width and record it. Next, insert the specimen into the HE116 thermal conductivity and clamp by heating plate, and then make sure the clamp was tight. Next, set the temperature at 45 darjah Celsius and switch on the heater, then stable after the heat at 45 Celsius. After that, temperature will be set at 45 darjah Celsius and switch on the heater. After that, stable for 10 minutes. And the data was displayed and the data will record at the table laboratory report. Next step will be repeat with cardboard, PMMA and plaster specimen. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Hakim bin Baharum and today I would like to present about the result and calculation for the experiment thermal conductivity of the solid. So first of all, we used that 4 specimen, which is a polystyrene, plaster, PMMA and last one is a cardboard. So the table 1 show that the result from the experiment data. And to calculate dimension, which is area and thickness, we use the vernier caliper. And the table 2 is we got the data from the calculate by using the formula from the lab sheet. So the formula of the thermal conductivity is negative heat flux multiplied with the thickness over area multiplied with the difference of temperature. And to calculate the thermal resistance is difference of temperature over to heat flux. Okay, the next is for the experiment multiple layer type. So the table 3 is we got the data from the experiment, and the table 4 is we got the data from the calculate by the formula from the lab sheet. So the formula of thermal conductivity same, which is negative heat flux multiply with the thickness over the area multiply with the difference of temperature. And the thermal resistance also same, the difference of temperature of the heat transfer. Okay, the next is observation. We observe that experiment for single layer type and the multiple layer type, the value of thermal conductivity and the value of thermal resistance was different from each type of material used. From the experiment, the value of the thermal conductivity and the thermal resistance have a little bit different if calculated by using formula from the theory. For example, the value of thermal conductivity of polystyrene specimen for the single layer type from measured experiment is negative 0.006 watt over meter Celsius, while the from calculate is negative 0.007 watt over meter Celsius. Meanwhile, the value of thermal resistant polystyrene specimen for single layer type from measured experiment is 23.2 Celsius over watt, while the from calculate is 23.81 Celsius over watt. Other than this, the value of thermal conductivity and the thermal resistance also have a little bit different if calculated by using formula from the theory for multiple layer type for polystyrene specimen from the measured experiment is negative 0.016 watt over meter Celsius, while the from calculate is negative 0.013 watt over meter Celsius. Meanwhile, the value of thermal resistant polystyrene specimen from the measured experiment is 12.79 Celsius over watt, while the from calculate is 12.86 Celsius over watt. So the last one is from observation for this experiment, the value of thermal conductivity and the value of the thermal resistance from the single layer type and multiple layer type also have a different value. The value of temperature of hot plate, cold plate, the value of heat flux, the value of heat transfer has important role to identify or to investigate of thermal conductivity and the thermal resistance. Thank you. Okay, the next is discussion and analysis. For an experiment, the value of the conductivity and the thermal resistance have a little bit different if calculated by using formula from the theory. For example, the value of thermal conductivity polystyrene for single layer type from measured experiment is negative 0.006 watt over meter per Celsius, while from calculate is negative 0.007 watt over meter Celsius. So, to calculate the percentage error, the formula is the result from the experiment minus result from the calculate over the value of the calculate and multiply with 100%. So we got that 14.29%. Meanwhile, the value of thermal resistant polystyrene specimen for single layer type from measured experiment is 23.2 Celsius over watt, while from the calculate is 23.81 Celsius over watt. So the value of percentage error for measure and calculate is 2.56%. Other than that, the value of thermal conductivity and the thermal resistance also have a little bit different if calculated by using formula from the theory for multiple layer type for polystyrene specimen from measured experiment. The value is negative 0.016 watt over meter per Celsius, while from the calculate is negative 0.013 watt over meter Celsius. So we got that the value of percentage error is 23%. Meanwhile, the value of thermal resistant polystyrene specimen from measured experiment is 12.79 Celsius over watt, while from the calculate is 12.86 Celsius over watt. So, okay, the value error may be due to several reasons. Firstly, instrumental error. Instrumental error happen when the instrument being used are inaccurate, such as the apparatus of HE116 thermal conductivity. Besides, human error. Human error is due to lack of consideration or to the limits of human ability. Two forms of human error are transcriptional error and error of measurement. Transcriptional error occur when data is incorrectly recorded or written down. Example of the Example of this are when a value is incorrectly copied or when a value is skipped when user type data into a computer program from a data sheet. While an interpretation error can occur when interpreting measurement on such as instrument. For example, when reading a vernier caliper during the measurement of length, thickness and width of the specimen.
Next, for the single layer and multiple layer of the specimen, it also have different value of conductivity. For example, for the single layer, the thermal resistance of the polystyrene have higher value compared to other specimens. And for the multiple layer, the value of the cardboard is the highest from the other specimen, but the value is not very large. Thank you. Alright, now I'm gonna explain the remaining of the discussion. From the experiment, each type of specimen have different value thermal conductivity. From experiment for single layer type of specimen, the value of polystyrene specimen is higher from the other specimen. It is because the polystyrene have good thermal insulation. Besides, thermal conductivity is a material asset. It does not different in size of the depends on the different size of the material, but depends on the temperature, density, and moisture content of the material. The thermal conductivity of a substance depends on its temperature, density, and amount of moisture. Alright, for the final conclusion. The conclusion is, in conclusion, heat transport in solids continuous regardless of the atomistic structure. Thermal conductivity is a property of matter that either allows it to transfer heat readily from a hot to cold object or it does not. So, for an example, in a kettle, there is the part of the material that use the high heat conductivity material and low conductivity material. It is important because the part of the high heat conductivity material needed to boil the water, and the low conductivity heat material needed for human to hold the kettle so that they won't get burned another. So in short conclusion, the ability of the material that to transfer that heat is called as thermal conductivity, and metals are very good at conducting heat. That is because they share their electrons in this delocalized cloud, and so the electrons are actually transferring heat. If we were to take something like wood, it is going to have low thermal conductivity. If I were to put it between the hot and the cold objects, heat is still going to be transferred. But from the hot object to the cold object, but since they are not this free electron, it is not going to be transferred easily. That is from us. Thank you for watching. See you later. Assalamualaikum.